Hey guys, I'm Nick, and I'm glad to see you here. I'm really grateful for your trust to join my Patreon at early stages. I am doing my best to produce quality content, and actually your support allows me to create even more content than I initially thought. So there will be more tutorials about various simulations in Houdini and even maybe covering redshift rendering, so it's definitely more to come. Don't forget about the Cozy Plays Discord channel, because in order to get all the perks that you pledged for, I have live streams, artwork critiques, help, feedback, all of the stuff that should be in a great community. That all is at our Cozy Plays Discord server, so definitely join that. And from this month, both solver and multi-solver tiers are welcome to participate in our bi-weekly artwork critiques. So on Monday, April 11th at 3 p.m. GMT, I will be hosting a live critique session in Discord. And till this week, Saturday, you are very welcome to submit your artworks in Artwork Critique channel on Discord, and then on Monday we will have a live call and everyone will be able to critique everyone's artworks. So that's how we can really gather some constructive critique from different viewpoints and share experience between us. I think that could be really cool live session. So Monday, April 11th at 3 p.m. GMT. And now let's hop in Houdini and see what we've got there. Alright, so here we have our flippity-whippity surface particle flow. Super fun setup, which is not that complex but very flexible, so you can adjust different parameters in order to get really unique looks. The technique here is adopted from an article of the team that was doing Lenovo tablet commercial. They are credited in the notes in the file, but as always with Houdini, there are millions of ways to do something, so I modified their approach to be a bit easier to understand, especially if you are transitioning from Cinema 4D or overall don't want to spend hours learning Vex. So here we are in Houdini, and as you can see, I have my particle geometry, sort of a backplate geometry, camera, one redshift light, and one material network. Let's start with the particles and see what we've got here. The setup is super easy, but I was looking to create this effect for quite a long time. So here we are, we start with a box. Let me actually remove this backplate and maybe this light, so we, here in the light, you should unchecked, enable it in viewport, so it doesn't affect the viewport part here. So for the particles, yeah, we got our box, which is primitive type polygon mesh, default size 2, 0.01 and 1. And then we transform it using the expression $y min, which will place our box exactly at the floor. See, here we have our box without the transform, and here it is with this little expression. So right now, yeah, it lays on the floor, so you can create any shape. You can even trace sort of a PNG something and then create an effect from that. So now we drop a dopnet, and here everything is default. Just drop the dopnet, and you can see we will need a flip solver, gravity, flip fluid object that goes into the flip solver's first input, and this pop color is absolutely optional. It's just like to visualize better. But yeah, so you drop the flip solver, and here what we need to do. Actually, yeah, let's start with the flip fluid object. So for the initial data, you wanna import our transform node, or like our box, but actually the transform node because it's the last in the chain. So here for the input type, we wanna select a surface SOP, and the SOP path should be our transform. You wanna check closed boundaries. All of them should be closed. For the guides, I'm just like visualizing it as a particles and scale it up them a little bit. So particle radius scale is set to 1 and particle separation is set to 0.0025, which is kind of like a production quality. For the preview purposes, while you are working on LugaDev, I would say you can try going something like 0.0125. But actually, here you should make sure that the height of your container should be more than particle separation radius. So we can try, let's say 0.065, and then if we enable, now you can see all these particles. So now let's go to the flip solver, and here you can see that minimum substeps is set to 3, max substeps set to 4. Particle motion, so we want to add ID attribute, we want to uncheck recede particles, and for the separation we want to check apply particle separation. For the volume motion, I'm using swirly velocity transfer method, so it's set to epic. By default it's flip, so yeah, we need epic. We also want to set the volume limits in volume motion. It should be exactly like our box, so 2, 0.01, 1, and the box center should be 0.005, which is basically our height divided by 2. I think that's it for the flip solver itself. So right now, if you simulate that, and let's pretend that you just have your flip fluid object, it should be just like this. So it's basically nothing. It does nothing. To better visualize, we can decrease the particle separation, let's say like this. So now we just need to plug the pop-wop into our second input, which is particle velocity. So here's the deal. We go into the pop-wop, and only thing we need to do here is to add force, which is generated by the noise. So we drop a curl noise 2D, noise type is set to Perlin. In this scenario, I'm using frequency 0.3, 0.6, and 0.6, amplitude 0.7, and turbulence 6. Others are left default, and we plug the P to the position of our noise. And here, this is kind of tricky moment, because the denser you are creating the flip fluid, I mean the less your particle separation will be, the more your amplitude should be also, and maybe the less frequency. So here you will spend some time to just find out which of these settings works for you best, but these worked really well with particle separation 0.0025. Then yeah, we just add our curl noise to we plug the noise into the force. And now let me visualize that so I can show you what it actually does. So here I just quickly simulated around 100 frames, and you can see how the noise is affecting particles. This colors is determined by this pop color node, which goes into the sourcing. And here you can see that I'm using color type set to ramp, and ramp is equals to Y position of each particle, and the range is from 0 to 0.01, which is the height of our box, but you need to bear in mind that we also have gravity, so there won't be as many particles at the top of the box, because naturally they are trying to go down affected by their gravity. And in this case you can see that we have major black part here, which means that all the particles are really close to the ground here, and in this case you should tweak the pop-wop parameters, especially I think the amplitude. Also, what I want to show you is that if we go here in flip fluid object and set this to 0025 as it was in my example, and let's say we simulate that. So here you see that I've simulated just a few frames and we don't have these black spots. So if we are setting the particle separation to 0025, it looks a bit different. So definitely you should experiment with the noise and particle separation combinations. So once you are good with that, you can drop a DOP import and just drag and drop the DOP net here in the DOP network. Import style should be fetch unpack geometry from DOP network, and then you can file cache all of that. In my case, I have simulated 120 frames, which is not that much, but actually it's enough for just 6 or maybe 10 frames, because we will be using time warp to slow it all down. Now here I have also added an attribute wrangle because I want to target the y-axis position of each particle, and I cannot do that in color node, so I needed to do attr, which is just a generic kind of like my attribute short form. So yeah, and then you drop a color, and color type should be ramp from attribute. Attribute should be attr, which is the thing that we just created, and range should be 0 to 0.01, which is the height of our box. So here you can do multiple crazy things with these color nodes, right? So you can do something like this, or something like a sand, or in my case, I actually using these colors here to create this sort of a blue something. Also, I add an attribute remap, and I remap my attribute, which is from 0 to 0.01 to p scale. Original name m attribute, new name p scale, and output min should be 0.01 and output max should be 0.005. So now the particles that are positioned higher will be also bigger. You can experiment with these values here to create differently sized particles. Now I'm dropping a retime node, which I just called slow-mo. And basically what I'm doing here is evaluation mode set to by speed, start frame set to 30 because I don't want these small ripples here. So here in the retime, output frame should be 1 to 200 and input frame range should be 30 and 100. So we are retiming 90 frames to be 200 frames. Here in the interpolation, interpolate between input frames and interpolate rotation of normals, quaternions and transformation should be all checked, and use velocity when interpolating position should be also checked. Here in point ID attribute, we add our ID and primitive ID attribute its name, but we are not using that, but it's just crucial to add ID here in point ID attribute. Now let's see what we got. Obviously the playback is slower because it should just like calculate all that stuff. But yeah, we got all of that. And now here's a little trick I learned from that article. So basically what we are doing here is we want to do 2 time shifts. One of that should be just like default, so it's not doing anything. And the second one should be with a slight offset, and in my case it's 30 frames before. So basically you can see that if I visualize that, it's nothing moving until we hit the frame 30, and frame 30 in our case will be frame 0, and then we go. Then for that time shift with an offset we add a rest node. It's all default here in the rest, but then we're using blend shapes and blending 2 of these. The blend should be set to, in my case it's 0.5, but you can experiment with that, and it just results in a bit more organic and smoother movement here. And now, which to me is really the key of this little setup, is to add an attribute warp. And let's go here. Here you can see that I'm using a noise. So amplitude set to 0.14, roughness to 0.561, and max octaves to 4, 3D frequency set to 111. And we plug the position into noise, and we plug the time, which is divided with constant. Constant is set to 15, and we plug that into our offset. And then we grab also our position, we drag it to the vector to float. We then add float to vector, and basically x from the vector to float goes to float to vector, and z from the vector to float goes to float to vector. But for the y, we are adding our noise to the base position, and then we plug that to p, which is our output position. So basically we are adding that noise. We're using basically a mountain node here, but it was just one vector which goes up, so we are only deforming it in a, let's say, y-axis. And if I hit that, you will see that immediately we can see the deformation of this grid with the points. Now we just add our null, we call it out, and let's set up cameras, materials, lights, and render it out with Redshift. So let me open up this camera I have here. Let's select the cam 1, and here's what our camera is seeing right now. So for the camera settings, transform, obviously self-explanatory. Resolution vertical for, let's say, Instagram stories or reels. Focal length set to 80, aperture set to 50. Near clipping, far clipping. I actually think that this should be 0. So yeah, sampling. This comes from the Redshift viewer, and in the Redshift camera I enable depth of field. use Houdini camera for focus and f-stop, tweaked photographic exposure and post effects just a little bit, so yeah, that's totally up to you. For the RS light, there's just one light source, intensity set to 15, and it is basically a rectangle light going in from this side. Let me also open up the Redshift viewer so it's easier for you to understand where's what. Let's go and grab our camera. We can make it this even a bit more narrow like this, and let's hit render. So here it is. As you can see, there is quite a lot of depth of field, but that's what I really wanted with these little particles, because it's not that interesting when they are all in focus, right? And yeah, again, the RS light, super simple light from just one side. Now let's go check out the materials. Oh, and actually, yeah, first of all, here in the particles, Redshift OBJ, particles render object as particles, and global scale multiplier, in this case, it's 0.3, but you should always check it yourself, because it might be 0.5, 1, I don't know, anything. Now let's go to the materials. So for our backplate is just simple, sort of a diffuse, or I mean glossy with a high roughness material, and it's basically black backplate. For the actual particles, it's a little bit more interesting. So we drop a particle attribute lookup, and attribute name should be CD. And that CD, that color from a particle attribute lookup, we can plug as a base diffuse color for our material. Here it's roughness set to 0.6, 0.59, and it also goes into the surface of our out redshift material. And then, for example, here in backplate, we go into the render tab and we specify our backplate material, and here in the particles we go to the render tab and we specify our particles material. So let's enable the backplate though. Yeah, and also there was one thing that actually helped a lot, which is called motion blur. So if we go here in the particles, Redshift OBJ, settings, render, be sure to check this enable instances particles motion blur. And now we go into our, I think, out. We have our Redshift ROP. So here let's check out the settings. So of course we don't want to override the camera resolution, we want the full res. Then the output, everything's default here. I'm using PNGs as an output. Post effects, all default. All right, so for the Redshift, advanced tab should be on. For the sampling, these progressive passes actually doesn't do anything. So yeah, we basically go to the unified sampling and turn off automatic sampling. And in my case, I'm using 256 minimum samples and maximum samples set 1024. That's basically it here. We should enable motion blur, and instances particles blur should be also on. You won't be seeing it here until you check this button here. And just for preview purposes, you can see there's really a lot of motion blur, right? So what we can do is restart it. For deformation particle steps, let's say we want 3 steps, and here how to decrease decrease the motion blur. You can, let's say here I'll revert to defaults, and we want something like start 25 and 45. So now let me show you how it will look with a bit less motion blur. It might be still too much, or actually no, should be good. I think we can decrease it to something like 30, because we actually don't want a lot of motion blur here. So yeah, I think around 0.3 or 0.4 should be actually good. So after we do that, let's go into globals, OCIO rendering space ACG. In the globals, be sure to uncheck the default light. Global illumination, brute force set to 8, radiance point cloud set to 1000, caustics disabled, volume scattering disabled, optimization system, yeah, that's default. So yeah, and then I just render it out. I was rendering from 30 to 240 just because of that time shift offset, because basically it's static before frame 30 because we don't have that offset time shift to work with the blend shapes. So that's why you will be starting from the frame that is kind of like that offset in the blend shapes. So that's basically it. I really hope it was helpful, and I was pretty stoked when I found out how to do this effect. And let me know if this was useful, if everything was clear. If any questions, you can reach out to me in our Cozy Place Discord. You are very welcome there, and I'll make sure to answer all of your questions. I hope you enjoyed this tutorial, and I will be back very soon. Bye!